Hello, this is Mrs. Decker, and in this video I'm going to go over Objective 2.2a on drawing dot diagrams for the main group elements. So let's start by understanding what a dot diagram is. A dot diagram shows us the arrangement of the valence electrons around an atom. And to help us draw the dot diagrams, we use the rhyme 12, 3, 6, 9, one at a time. So 12, 3, 6, 9 are like the positions on a clock. Okay, so let's say we have symbol X. We have 2 positions at 12 for electrons, 2 at 3, 2 at 6, and 2 at 9. So you would just draw the dots around the element, but you want to draw one on each side of the element before you start doubling them up. So that would be 12, 3, 6, 9, and that would be 4, one at a time. And then if you need more, you would go in and fill them in pairs next to each other. Okay? So the way this element is drawn, this would have 8 valence electrons. So that would be like a noble gas that has its full valence shell. Okay? So the first part of this is to understand the number of valence electrons that there are. So for hydrogen, remember we're going to use the periodic table. Hydrogen is in group 1a, which means it has 1 valence electron. So to draw the dot diagram, you draw the symbol. So the symbol is H for hydrogen, and it just has 1 valence electron. So you put 1 dot on the top of hydrogen like that, and that is it. That's done. Okay. Next up, we have lithium. Lithium is also in group 1a, so it also has 1 valence electron. So you want to draw the symbol for lithium, which is Li, and then draw 1 dot on the top of lithium to represent the 1 valence electron, and lithium is done. Next, we have carbon. Carbon is in group 4a, which means it has 4 valence electrons. So draw the symbol for carbon, and we need to draw 4 dots around carbon, but remember we cannot pair them up until we have 1 dot on each side. So that is what carbon should look like. It should have 1 dot on each side. Next up, we have nitrogen. Nitrogen is in group 5a, which means it has 5 valence electrons. So draw the symbol, draw the N. So you will start 1, 2, 3, 4, 1 on each side. And then you need 1 more. So add a second dot on top there. And that's what nitrogen should look like. All right, next up we have oxygen. Oxygen is in group 6a, which means it has 6 valence electrons. So you draw 1 on each side, and that's 4 valence electrons. We need to make it 6, so draw a second one there, and a second one there. And that is the dot diagram for oxygen. Next up is fluorine. Fluorine is in group 7a, which means it has 7 valence electrons. So draw your F, the symbol for fluorine. Draw 1 on each side. That's 4. We need to get to 7. So draw a second one on top, on the right side, and then on the bottom. And that's the diagram for fluorine. And lastly, we have neon. Neon is in group 8a, which means it has 8 valence electrons. So draw the symbol for neon. 1 electron on each side. And you need 4 more, so then go back and add 1 more electron to each side. And that is the dot diagram for neon. Okay, so now in class we've talked about the octet rule a little bit, and I have a quick YouTube video that I'm going to have you watch on the octet rule.
I want to talk to you guys about a basic rule in chemistry called the octet rule. So we know that atoms love to be stable. And the way an atom can achieve stability is by having a complete number of electrons, valence electrons, in the outer energy level. These valence electrons will allow atoms to have different properties. The octet rule states that an atom will gain or lose electrons to obtain 8 electrons in its outer shell. In other words, elements want to reach an electron configuration of the nearest noble gas. The word octet means a group of 8. For example, an octopus is an animal with 8 legs. An octagon is a shape with 8 sides. So let's look at a model of an atom. We know that an atom has a nucleus, where the protons and neutrons are located. Around the nucleus, we know that there are electron shells where all the electrons are located. The first electron shell in an atom can hold 2 electrons maximum. The electrons in the outermost shell are called valence electrons, which determine the properties of the atom. The second electron shell can hold a maximum of 8 electrons. In this case, the electrons in the second electron shell are called the valence electrons. The third electron shell can also hold a maximum of 8 electrons. In this case, the electrons in the third electron shell are called valence electrons, and so on. So let's look at the element lithium. Lithium is in group 1 of the periodic table, and since it's in group 1, it has 1 electron in its outermost shell. Another example is an element that is in group 16 of the periodic table. It will have 6 valence electrons. Elements in the same column as group 16 will also have 6 valence electrons. This is a general way to figure out the number of electrons for an element. Elements like to be in their most stable electron configuration. So the easiest thing for lithium to do is lose that 1 electron in its outermost shell to obtain the electron configuration of the noble gas helium. Helium is a very stable element because of its electron configuration. Sodium, like lithium, is also in group 1 and has 1 valence electron. Notice the lonely valence electron in the third shell of the atom. This shell needs 7 more electrons to satisfy the octet rule, but the easiest thing for sodium to do is lose that electron if it can. And when it does, sodium will now have the electron configuration of the noble gas neon. Now let's look at chlorine. Chlorine is in group 17, which indicates it has 7 valence electrons. So looking at the chlorine atom, notice how the outermost shell needs 1 more electron to satisfy the octet rule and have 8 electrons to be stable. That's why chlorine is a very reactive element, because it just needs 1 more electron. And when it does, it will have the stable electron configuration of noble gas argon. And that is the octet rule.
All right, so the next page of your packet is practice for you to work on. I just want to go through with you how to do this so that you know. Right? So the first one there is the element sodium. It is in group 1A, so it has 1 valence electron. So draw the element symbol and 1 valence electron on the top. So now for the third column here, you need to decide whether it will gain or lose electrons. Since sodium only has 1 valence electron and it wants to get to 8 in its outer shell, it's easier for it to lose that 1 valence electron than to gain 7. So it will lose 1. And then once it loses that 1 valence electron, its overall valence charge will be +1 because remember, it's losing a negative charge. I'll do one more with you here. Be has 2 valence electrons because it is in group 2A. So draw the symbol for Be, and we're going to draw 2 valence electrons, one on the top and one on the side. So again, we need to decide whether it's going to gain or lose electrons to get a full outer shell. And here it will be easier for beryllium to lose these 2 valence electrons than it would be for it to gain 6. So here it will lose 2. And then once it loses 2, its valence charge will become +2. So now go ahead and finish the problems on this worksheet and let me know if you need any help.